Good day and welcome back to our channel. Now let's discuss Lab 6, which is interfacing 4x4 keypad with Arduino UNO board. The objectives of this laboratory are to introduce the student to Arduino UNO hardware, Arduino software, writing, compiling, downloading, and testing programs to control 4x4 keypad using digital inputs on the Arduino UNO, and lastly, interfacing various devices such as LEDs, switches, and piezo buzzers, and keypad. Now let's go to the program 1, which is this, which is first we need to connect the Arduino UNO R3 compatible board to the 4x4 keypad as indicated in the given table and graphics below. So since I'm just gonna simulate this first on the Tinkercad and then later we'll use it on the actual board. So first, this is the connections and this is the code, which is also indicated here, or rather given here. And this code is for the including the library of the keypad. Next is the components or constants, which is for rows. Rows and for columns. Next is the array of the keypad, wherein each element corresponds to a key on the keypad, which is 1, 2, 3A, 4, 5, 6B, 7, 8, 9C, asterisk 0, hashtag D. And this code is for the connection of the pins on the keypad, wherein pin 9, 8, 7, 6 corresponds to the row, which is this is connected to pin 9, it's connected to pin 8, this is connected to pin 7, this is connected to pin 6, and for the column, this is connected to pin 5, this is connected to pin 4, this is connected to pin 3, this is connected to pin 2. So this code is for, well, initializing the instance of class, which is new keypad. It creates an instance on the keypad class, wherein it also uses the key map, row pins, and column pins to initialize the keypad. And for the loop, it checks if a key on the keypad is pressed, this get key thing, and then if a key is pressed and custom key is not null, it prints the key value to the serial monitor using this serial print in. So now let's try it out here in the Tinkercad. Let's drag it up a bit, and there, let's press 1, 2, 3, A, 4, 5, 6, B, 7, 8, 9, C, asterisk 0, hashtag D. And before we can run this, we must import the keypad library, which is here, tools, manage libraries, and there, we already have it installed. Now, let's go and test this on the actual board.
Now let us show you Program 2, Arduino Jukebox. Create and design a musical jukebox, a menu-driven system running on serial monitor screen using a keypad, comprising 6 preschool rhyme songs or any 6 songs of your choice. With the use of switches, the user can select songs to be played by Arduino. Provide a running light pattern for each song and played as accompanied by the song being played. You might be familiar with this program that we're going to present to you for a laboratory exercise number 6, since this program 2 is also similar to the previous program 2 we've created way back from the last video we uploaded tackling our laboratory exercise number 5. But this time, we're going to utilize the keypad to select a song from the menu. To have a better understanding of this program's functionality, let us start the simulation here in Tinkercad. The keypad provides an input to the Arduino so we could select any of these 6 songs to be played by simply pressing a number corresponding to a song. As we start the simulation, and let's open the serial monitor. As we start the simulation, we will have a view of the serial monitor where the menu is shown, which is right here. Pressing 1 should play the song Twinkle Twinkle Little Star. Let's try it out to see if our program and circuitry works. As you can see, our Arduino jukebox successfully played Twinkle Twinkle Little Star by pressing 1, and the LED light synchronized with the song as well. And you can also see here at the serial monitor, the same Arduino jukebox menu is presented again so that you can select another song to play. Achieving this functionality involves creating an Arduino sketch for the program. Let us view and explain our sketch on the Arduino IDE. In this section of the sketch that I have highlighted, this library is included to handle the keypad input. Here, we define the pin for the buzzer and an array of pins for the LEDs. We also calculate the number of LEDs using the size of the array. For this section, this part of the code defines the 4x4 keypad layout and associates rows and columns with specific pins. This function is responsible for playing a tone with a given frequency and duration. It also handles lighting up the LEDs sequentially to provide visual feedback. And now for this entire section of the code, which are actually related to the 6 songs that we have composed using the Piezo Buzzer. For this entire section of the code, starting from here, all the way in here, these song functions play a series of tones corresponding to the notes of the song. Now for this section, the setup function initializes the serial communication and sets the buzzer and LED pins as outputs. It also prints a menu of available songs to the serial monitor. Finally, this last part of the sketch reads the key pressed on the 4x4 keypad to determine which song to play. When a valid key is pressed, corresponding to numbers 1 through 6, the program calls a specific function to play the selected song. After the song finishes playing, the menu is reprinted on the serial monitor to prompt the user for another selection. This loop allows for continuous user interaction, enabling multiple songs to be played based on keypad inputs. Now, let us upload this compiled sketch to the Arduino UNO itself so we can see if the codes within this sketch or program does execute our own design or functionality as specified on the documentation for Program 2.
So now, let's proceed to demonstrate the program 3 of this lab activity, a hexadecimal calculator. Create and design a hexadecimal calculator that can perform the following mathematical operations, such as addition, subtraction, multiplication, and division. The mathematical expression formed from typing it via the keypad is being displayed over the serial monitor screen, as well as the output of the said mathematical expression. Now, let's proceed to Tinkercad to show the schematic diagram created for this program and to demonstrate its circuit diagram. So, this is the schematic diagram of this program. And here's the circuit diagram for this program. As you can see, the pins representing the rows and columns of the keypad, these, are connected to the Arduino board. The row 1 to 4 pins are connected to the pin 9 to 6 of the Arduino board respectively, and column 1 to 4 are connected to the pins 5 to 2 of the Arduino board respectively. Now, let's see the created sketch for this program. And we will explain it to the actual Arduino IDE. The line 1 initiates the keypad library, which allows the code to interact with a matrix keypad. Yes, we use this library for easier configuration of the keypad. In this part, we initiated a two-dimensional character array for mapping each button on the keypad. Then, we declared arrays for the row pins that uses pin 9 to 6 and column pins that uses 5 to 2 pins. And after that, this line of code creates an instance of the keypad class, the one with the capital letter K, which is part of the keypad library, and the small k keypad is its object. The keypad that is color orange calls the constructor of the keypad class. MakeKeymap is a function provided by the keypad library that converts a 2D array of characters into a format that the keypad class can understand. Keys is a 4x4 array that represents the layout of the keypad, where each character corresponds to a key on the keypad. The row pins and column pins are arrays that specify which Arduino pins are connected to the rows and columns of the keypad matrix. And lastly, these two values specify the number of rows and columns in the keypad matrix. In this case, the keypad has 4 rows and 4 columns. Now, this part of the code, we declared global variables that will be used later in the code. First, the initialized string variable buffer with a value of blank string stores the inputted value as a string for displaying at a serial monitor. Then, we initialize integer variables named first_num and second_num as 0 to store the first and second operands of the calculation. Lastly, we initialize the character variable named operation that has a value of null as a container for the inputted operation. And here, declare the enumeration named as calculator state to define the different states that a calculator can be during its operation. Each state corresponds to a specific part of the input and calculation process. As you can see, first is the input first value, then input second value, then input operation, confirm operation, and lastly, calculate result. The calculator state variable current state is used to keep track of the calculator's current state. It is initialized to input first value, indicating that when the program starts, it is ready to receive the first number from the user. Then, we declared void functions here to be declared at the beginning of the code and defined later. They are called within the loop function to handle various stages of the calculator's operation based on the current state variable. These are on void since they will not return a value from the caller. Based on their rules, these functions are used to handle value input, handle operation intake, confirm operation, calculate, and clear current input. The void setup function, we initialize the serial monitor here and the set of instructions of the hexadecimal calculator. And in the loop function, the character value named here reads the current key pressed on the keypad. After that, we use if statement here that has a condition inside to check if there's any key that has been pressed. No key is pressed. The key will be null, which evaluates to false. Inside here, there's a nested if statement, which says that when a asterisk button is pressed, the current input will be cleared. The nested else statement, there's a switch statement that checks the value of the current state to determine what to do with the press key. Each case in the switch statement corresponds to different state of the calculator. Next, in the handle value input function, it handles input for the first and second values. Here will be found codes for the following functionalities of the calculator, such as it appends valid hexadecimal digits to the buffer, double-clicking A will changes it to E, and double-clicking B changes it to F. It converts the putted hexadecimal to decimal value to calculate it, and the other function, the result will be converted to hexadecimal again. And pressing the sharp button converts the buffer to an integer and updates the state. Next, in the handle operation input function, it uses if statement and switch statements to set the operation based on the key press and transitions to confirm operation. Next, the confirm operation function transitions to calculate result when sharp button is clicked, or clears the input if asterisk button is pressed using if and else if statements. The calculate function It performs the chosen arithmetic operation and displays the result in hexadecimal. And then, if the division by 0 is attempted, it prints undefined. The last set of codes. The clear current input function resets the buffer and clears the current input based on the current state. It provides feedback to the user and resets relevant variables such as first underscore num, second underscore num, and operation. Now, let's try the program we've created on Tinkercad first to check if the program is working properly, then on actual Arduino after. So, let's start the simulation. And let's open the serial monitor since here's where the calculation will be displayed. So, as you can see, when we started the simulation, a set of instructions is shown for the hexadecimal calculator. So let's review. First, input the first value by clicking any hexadecimal digit in the keypad. Double-clicking A will give you E, and double-clicking B will give you F. Then, click the sharp button to proceed to input second value. Then, after inputting the second value, click the sharp button again to proceed to pick what operation will be used. And the following buttons are their corresponding operations. A is for plus sign, B is for minus sign, C is for multiplication sign, and D is for division sign. And lastly, click the sharp button again to get the result in hexadecimal value. And click the asterisk button if you want to clear the current input. So, let's start. Let's try to input the first value. For example, 23 and A. And to confirm it, just click the sharp button. And the program is asking for the second value. So let's try 16 and E. Then, if you want to clear the current input, just click the asterisk button. And the program is asking again for a second value. So now let's try 13F. And let's submit it. And let's input operation, for example, A for plus. And let's click this again for the result. And it says that the result is 379. So let's try it again. But now, we will use different operations. So, as you can see, the program works properly. Now, let's try it in actual Arduino board.
For the next program, this is our task. Program 4, Password-Driven Piezo Buzzer. Design our Arduino circuit for a password-driven running LEDs. The program will ask the user to enter a password. If the password is correct, it will buzz off the correct musical tone and a running LED will light from left towards right. Otherwise, it will display the incorrect running LED's pattern, together with a sound off from the buzzer, and ask again the user to enter the correct password. Provide 3 trials for entering of the correct password. At the last attempt, if still the password is incorrect, Arduino will disable the keypad. That is, it will no longer be accepting any entering of password. Now the task for this program is to draw the schematic using Tinkercad and to run the program and verify that it works properly. Now, let's open Tinkercad to see the schematic diagram and demonstrate the circuit diagram for this program. We use 6 LEDs, 1 piezo buzzer, a keypad, and 7 220 ohms resistor. If the user inputs an incorrect password, all the 6 LEDs will blink together and the piezo buzzer will play the Nokia ringtone. If the user inputs a correct password, the LEDs will blink from left to right and the buzzer will play the selecta theme song. Here's the code, but I'll explain later how we created it. Now, let's see if it works. Now, I will try to input an incorrect password. When we input an incorrect password multiple times, the keypad is disabled. Now let's try to input the correct password. As we can see, it works. Now, let me open the Arduino IDE to show you and explain the constructed code to be uploaded to the Arduino board for this program. So, for our first set of codes, this code includes the keypad and EEPROM libraries, which are essential for keypad operations and memory storage. Now, this next set of codes is that the keypad is defined with a 4x4 matrix specifying the characters for each key and the row and column pins. An object of the keypad class is created to handle keypad interactions. The global password is defined for access control. LED pins are assigned to an array for indicating status, and the buzzer pin is set up for audio feedback. Note frequencies are defined for playing melodies on the buzzer, covering a various musical notes. While here in the setup function, it initializes serial communication for debugging, sets the LED pins as outputs, and ensures they are initially off. The buzzer pin is also set as an output. In the loop function, it handles user interactions, prompting for a user name and password. It allows up to 3 attempts to enter the correct password, providing feedback and controlling access based on the entered password. If the correct password is entered, it triggers a success function. Otherwise, it disables the keypad after 3 failed attempts. These functions handle input from the user. The get username reads the username from the serial monitor, while get password reads the password from the keypad, masking input with asterisks for security. The selected theme song notes and Nokia ringtone notes defines the notes for success and failure melodies. Their corresponding tempos and sizes are also specified. The correct password function plays a success melody and lights up LEDs sequentially when the correct password is entered. While the incorrect password function plays a failure melody and lights up all LEDs when an incorrect password is entered. And lastly, the disable keypad function is designed to be called when access is permanently denied after 3 incorrect password attempts. To see if it works, let's create the circuit diagram on the actual Arduino board while trying the codes we have created.